Assalamu alaikum students, I am Wasim Ikram. This is the 5th lecture in a series of 45 lectures on digital logic design. How are you today? I hope you have been keeping well. आज एक नई टॉपिक पे बात करेंगे जो बड़ी इंटरेस्टिंग किस्म का टॉपिक है, एप्लीकेशन पे बात करेंगे इसमें. But before that, let us have a look at the material which we covered in the last lecture. In the last lecture, we looked at the octal number system, which is in fact a base 8 number system. It gives you 8 different values. Use कहाँ होता है octal number system? We said when you write long strings of binary numbers, then you could generate an error. लिखने में गलती हो सकती है उसमें. So to represent long strings of binary numbers, you use the octal representation. Hexadecimal number system के होते हुए octal number system इतना frequently use नहीं होता है. But still, since we are studying different number systems, so octal is again an important system, number system. We talked about converting from binary to octal, octal to binary, then octal to decimal, decimal to octal. Standard methods we use हो रहे हैं, divide by 8 वाला, sum of 8 method, वो सारे use हो रहे हैं. Next we talked about alternate representations. पहले हमने 4 representation की थी, 2's complement, unsigned and signed magnitude, floating point. इसके अलावा भी कुछ representations हैं जो खास applications में use हो रही हैं. We talked about the excess code. Excess code का main use कहाँ पे है? Floating point representation में हमने use किया था. 8 bit जो exponent field है उसको हम biased value के साथ represent कर रहे हैं, excess value के साथ represent कर रहे हैं. We also talked about the BCD code. BCD code we said was the binary coded decimal. When we need to display decimal numbers or write decimal numbers, we generate a binary code to represent those decimal digits 0 to 9. So we have to use a 4-bit binary code which has 10 different values to represent numbers 0 to 9 of course. Gray code की हमने बात की थी. Gray code we said is not a positional code जो बाकी binary codes हैं, hexadecimal number भी और octal number system भी सारे जो हैं positional code पे based कर रहे हैं. Gray code we said is not a positional based code. The important thing about gray code is that when you count, let's say 4 से अब 3 count कर रहे हैं या 4 से 5 count कर रहे हैं successive numbers, the number of bits that change is limited to 1. उसकी हमने एक एप्लीकेशन देखी थी. कोई आपके पास मोटर है, रोटेटिंग मशीन है, तो उसका आपने मालूम करना है कि किस एंगल पे वो है. सो यू अटैच ए डिस्क और उसको ग्रे कोड के थ्रू कोड कर लें उसमें. सो व्हेन द मशीन रोटेट्स यू वुड गेट टू सी डिफरेंट नंबर्स एंड दोज नंबर्स वुड रिप्रेजेंट द एक्चुअल पोजीशन इन टर्म्स ऑफ एंगल्स. वी ऑल्सो टॉक्ड अबाउट अल्फा न्यूमेरिकल कोड्स. अल्फा न्यूमेरिकल कोड की जरूरत इसलिए पड़ती है कि आपके पास जब आप टेक्स्ट लिखते हैं उसमें आपके पास कैरेक्टर्स आते हैं, ABCD, स्मॉल ABCD, पंक्चुएशन मार्क्स आ रहे हैं, उसमें नंबर्स भी होते हैं. अभी तक जितने भी हमने कोड्स डिस्कस की थी, दे ऑल डील विद पॉजिटिव, नेगेटिव नंबर्स, फ्रैक्शंस एंड ऑफ कोर्स इंटीजर्स. सो ASCII कोड इज ए 7-bit कोड व्हिच गिव्स यू अप टू 128 यूनिक सिंबल्स. हर एक सिंबल का एक बाइनरी 7-bit रिप्रेजेंटेशन बन रहा है जो कि आप डिजिटल सिस्टम में स्टोर कर रहे हैं और यूज कर रहे हैं. We talked about an extended version of the ASCII code, which is an 8-bit ASCII code. 8-bit ASCII code allows you up to 256 different characters or unique codes. इससे भी बढ़ के अगर आपको unique characters चाहिए, then you have another code, the Unicode, जिसमें 16-bit representation है, so you can represent up to 64,000 characters. The last 2 topics which we discussed was the detection of errors using the parity bit. So we said one way of detecting an error is to use the odd parity, the other way is to use the even parity. So both the methods are very similar. When you detect an error, you cannot correct it. वो एक अलग subject है. Up till now we have been talking about numbers or characters which we represent in terms of binary digits or bits. Now the important question is, ये सारी इन्फॉर्मेशन प्रोसेस कैसे करेंगे? जो डिजिटल सिस्टम्स हैं जिनको ये इन्फॉर्मेशन चाहिए वो इसको यूज कैसे कर रहे हैं उसमें? वेल, इन द फर्स्ट लेक्चर वी मेंशन दैट डिजिटल सिस्टम्स आर बेस्ड ऑन बेसिकली डिजिटल सर्किट्स, और जो बिल्डिंग ब्लॉक है दैट इज द लॉजिक गेट. सो लॉजिक गेट इज द मोस्ट इंपॉर्टेंट कंपोनेंट और द स्मॉलेस्ट कंपोनेंट व्हिच कैन बी कंबाइंड विद अदर लॉजिक गेट्स टू फॉर्म अ डिजिटल सर्किट. सो टुडे वी वुड बी टॉकिंग अबाउट लॉजिक गेट्स. Now, before we move on and discuss about logic gates, let's discuss an example. एक मोटरसाइकिल है. अब मोटरसाइकिल को यूज करने से पहले उसके बारे में आपको पता होना चाहिए. For example, how many liters of fuel does it require? What is its maximum speed? how frequently should you service the motorcycle, how much load can it carry, 3 बंदे नहीं बैठने, 2 बंदे बैठने उसमें. Now, if you meet or fulfill all the specifications, then of course you would be able to use the motorcycle for a longer duration of time. अगर आप उसको misuse कर रहे हैं तो जल्दी खराब हो जाएगा. Now, in electronic terms, each component which you use in an electric circuit has its specifications and characteristics. So each component has to be used based on those characteristics. For example, आपके पास एक ट्रांजिस्टर है. ट्रांजिस्टर के 3 पिन्स होती हैं इसमें. So before you can use the transistor, you should know कि वो करता क्या है. You should also know what are the input voltages and what are the output voltages. एक और important perhaps criteria है कि उसका gain क्या है. Input voltage जो आप उसको देंगे, output voltage क्या आ रहा है इसमें. Frequency response, there are different characteristics which you have to study. Now, when you implement an electric circuit, how would you describe it to somebody? Well, to describe an electric circuit which you have implemented, you draw a circuit diagram. It's like the architect who draws your house plan. जब आप घर बनाते हैं, आर्किटेक्ट जो है पहले सारा नक्शा बनाएगा, उसमें वो इंडिकेट करेगा दरवाजा किधर है, खिड़कियां किधर है, कमरा किधर है, किचन किधर है. Similarly, when you implement a digital circuit, you have to draw a circuit diagram. Circuit diagram में क्या होगा? Connections बताए होंगे कौन सा कंपोनेंट किसके साथ कनेक्ट हो रहा है. The components themselves, for example, ट्रांजिस्टर यूज हो रहा है तो कौन सा वाला ट्रांजिस्टर है. ट्रांजिस्टर को सर्किट डायग्राम में दिखाएंगे कैसे. उसका एक यूनिक सिंबल है. रेजिस्टर फॉर एग्जांपल, उसका क्या सिंबल है? वो इट्स ए जिगजैग लाइन. कैपेसिटर क्या है? कैपेसिटर आपको 2 हॉरिजॉन्टल लाइंस नजर आ रही होती हैं. सो दीज आर दी सिंबल्स ऑफ दीज कंपोनेंट्स. Now let's turn back to logic gates. Logic gates, we said, are the basic components or the basic building blocks of a digital circuit or a digital system. Now, when you design a digital system and implement it, you need to have its circuit diagram. In the circuit diagram, what do you see? You would be seeing all those gates which are connected to each other. So each gate would be uniquely represented by a symbol. Now, when you connect all these gates, you also need to know how these gates function. What are their characteristics? So today we would be looking at all these gates which are used in digital logic design or digital circuits, and we would be the issues which we would be looking at would of course be the symbol. Symbol एक gate का AND gate हम describe करेंगे, OR gate describe करेंगे. Symbol क्या है? What else? What is the other important information which you need to know about a gate? काम कैसे करता है? What is its function? क्या inputs देंगे, उसका output किस किस्म का आएगा. अब किसी को आपने एक गेट के बारे में बताना है. So how would you convey that information? Well, one way is to draw out a table. Table में आप जितने भी inputs हैं वो आप लिख देंगे कि ये inputs आ रहे हैं and the corresponding output values. So one way of describing the function of a logic gate is through a truth table or a function table where you list all the inputs and the corresponding output values. Another way of describing the function of a logic gate would be by writing a mathematical expression or a formula. So 2 ways of describing the function of a logic gate. The other important issue which we need to know about a logic gate is its performance for a certain period of time. Now, when you connect a logic gate in a circuit diagram, you would be continuously applying signals to its input. So for example, let's suppose एक AND gate है जो आप 10 सेकंड के लिए इस्तेमाल कर रहे हैं. For 10 seconds you would be varying the inputs. So of course, for the 10-second time period, you would be getting either different outputs or the same outputs. So you need to convey that information as well. So how would you convey that information, that how a gate works during that 10-second interval? Through a timing diagram. So when we describe an AND gate or any other gate, we would be describing or we would be identifying the gate through its symbol. We would be describing its function through a truth table or a function table. We can also write an expression which represents the operation or the function of the gate, and we would also be describing or writing out its timing diagram. So now let us look at the different gates which are used in digital logic circuits. Basically, there are 3 gates which are used: the AND gate, the OR gate, and the inverter. Let us start by looking at the AND gate. Now, an AND gate is represented by a symbol which is a closed U lying on its side. You will see the exact diagram of the symbol which represents the AND gate. An AND gate can have a number of inputs. but it has to be more than 1. So it could be a 2 input AND gate, 3 input, 4 input, multiple inputs can be there. And a AND gate always has a single output. So if you see the symbol of a 2 input AND gate, you would see 2 lines which represent the 2 inputs, and a 1 line at the other end towards the curved end of the U, which indicates the output of the AND gate. So this is the symbol. If it's a 3 input AND gate, you would see 3 lines at the input indicating the 3 different inputs. So multiple input AND gates would have multiple lines at the input end. Now, how would you describe the operation of this AND gate? We said we would be using a truth table or a function table. Let us consider the example of a 2 input AND gate. कितनी possibilities हो सकती हैं, कितने different हम inputs दे सकते हैं to a 2 input AND gate. Of course binary में बात कर रहे हैं. So look, you could apply both zeros at both inputs, or a combination of 0 and a 1, or 1 0 or 1 1. So 4 possible combinations आप apply कर सकते हैं at the input of a 2 input AND gate. What is the output for each of these 4 combinations? अगर 0 0 input है, the output is 0. अगर 0 1 input है, the output is again 0. अगर input 1 0 है, the output is again 0. Only for the inputs 1 1, the output is 1. ये basically कौन सा function implement कर रहा है? Well, if you remember, जब हमने binary multiplication की बात की थी, binary multiplication में exactly यही हो रहा था. When we multiplied 2 single binary bits, then when both the bits were ones, only then the answer was a 1. For all other combinations, the answer was a 0. So अगर आपको कोई कहे कि आप multiplication implement करें for binary numbers, of course, well, you can use an AND gate. It implements the multiply function. Now, how would you represent the operation or the function of this AND gate in terms of an equation? Well, let us consider that F indicates the output of the AND gate, and A input A and B indicates the 2 inputs of the AND gate. So the equation would be, or the function representing the operation of the AND gate would be F equals to A dot B. The dot is the AND operator. Now, if the AND gate is a multiple input AND gate, let's suppose 4 inputs हैं, A, B, C and D. So फिर कैसे आप लिखेंगे उसकी expression? It would be F equals to A dot B dot C dot D. 4 input AND gate का जो table या function table क्या होगा? Well, it would have 4 inputs or 4 input columns A, B, C, D and a single output column F. कितनी possible combinations हैं? Remember, 4 bit input है. So if you use a 4 bit input binary number, you can get 16 different combinations. So in 16 different input combinations के 16 different outputs होंगे. क्या outputs होंगे आपके ख्याल से? Well, for all cases except for the case where the inputs are all ones, the output would be 0. So once again, अगर आपका input जो है तमाम ones हैं, the output would be 1. For all other cases, the output would be a 0. So this satisfies the function, the expression which we had written. यहाँ multiply function जो है उसको satisfy कर रहा है इसमें. Now let us look at the timing diagram. Let's suppose you connect this 2 input AND gate and you apply different inputs for, let's say, a time period of 10 seconds. Inputs vary कर रहे हैं उसमें. So what do you get at the output? You would get 10 different outputs or perhaps the same output. It depends on the input values. इस टाइमिंग डायग्राम को कैसे आप देखेंगे, कैसे इसको समझेंगे? So let us have a look at a slide which shows the timing diagram of an AND gate. The combination of ones and zeros applied at the A input of the AND gate is represented by the timing diagram, the timing shape A. The combination of zeros and ones applied at the B input of the AND gate is shown by the wave shape B. Now both these inputs vary over a time period of 7 time intervals, T0 to T6. Now let's have a look at the output. Now in the time interval T0, the input A and B both are logic 1. So what is the output? Well, considering the function table, the output has to be a 1. Consider the time interval T1. The input A is 0, the input B is 1. So what should be the output? It should be 0. Similarly, at time interval T2, the input A is 1, the input B is 0. The output is again 0. At time interval T3, both the inputs A and B are logic 1. The output should be 1 as seen in the timing diagram F. At intervals T4, T5 and T6, the output is 0 because the inputs have a 0 value. The timing diagram which we saw describes the operation of the AND gate for 7 time intervals. Well, we can extend this time interval to, let's say, 100 time intervals or 200 time intervals. The thing which I forgot to tell you, there is an alternate symbol which represents the AND gate. It is a square with one pin at the output, which indicates the output, and 2 lines at the input side. Within the square, you have an ampersand symbol, which basically indicates an AND gate. Now, let us look at the OR gate. The OR gate is represented by a symbol which is similar to a V lying on its side. The V is a closed V, of course. The corner of the V has the output of the OR gate, and the other end, the closed end of the V, has the inputs. So, like the AND gate, OR gate can be a multiple input OR gate. Of course, inputs have to be more than 1. So, the minimum number of inputs have to be 2, maximum 10 भी हो सकते हैं, 12 भी हो सकते हैं उसमें. Normally, जो आप use कर रहे होते हैं, you have 3 input OR gates, 4 input, 5, 6 तक जा रहे होते हैं. Now, how does an OR gate function, or rather, what is the function of an OR gate? Now, that can be described by looking at the function table or the truth table of an OR gate. Let us consider the 2 input OR gate. Now, how many inputs? Of course, 2 inputs, so input A, input B. How many outputs? Of course, OR gates have a single output. So, the output is output F. How many input combinations can we apply to a 2 input OR gate? Again, it's 2 raised to power 2, so 4 different input combinations. What are those input combinations? Well, 0, 0, 0, 1, 1, 0, and 1, 1. Output क्या आएगा? Well, for the combination 0, 0, the output is 0. For the combination 0, 1, the output is a 1. For the input combination 1, 0, the output is again a 1. For the input combination 1, 1, the output is again 1. So, OR gate के केस में जब इनपुट दोनों इनपुट्स अगर 0 हो, ओनली देन द आउटपुट इज 0. फॉर ऑल अदर केसेस द आउटपुट इज 1. इसको अगर आप देखें, इसको कंपेयर करें, एंड इफ यू रिकॉल बाइनरी एडिशन जब हमने की थी उसमें क्या था, वेरी सिमिलर. जब हमने 1 और 1 को ऐड किया था, वी हैड ए सम पार्ट विच वाज 0 एंड ए कैरी पार्ट. ठीक है, अगर OR गेट के ऑपरेशन को देखें, सो वो 1 और 1 इज डिफरेंट, बाकी तकरीबन मिलता जुलता है. Right? So, OR gate operation is described as a Boolean addition. Now, what happens if we have a 3 input or a 4 input OR gate? वो कैसे behave करेगा? Well, let's consider the example of a 4 input OR gate. So, 4 inputs होंगे A, B, C and D. Output of course एक ही रहेगा F. Again, कितनी combinations, input combinations हो सकती हैं? Well, 4 bits हैं, 4 inputs हैं, so 16 different combinations हो सकती हैं. 2 raised to power 4, 16. Now, one output जो है किन combinations के लिए आएगा? Well, if you look at the function table or the truth table for the 2 input OR gate, you would see that again, if all the 4 inputs are all zeros, only then the output would be 0. For all other combinations, of course, the output would be a 1. अच्छा, ये जो OR gate का फंक्शन है, एक तो तरीका हमने ये बता दिया कि ट्रुथ टेबल या फंक्शन टेबल से आप डिस्क्राइब कर रहे हैं, राइट? इसको इक्वेशन की फॉर्म में या एक्सप्रेशन की फॉर्म में कैसे लिखा जाएगा? Well, let's again consider the example of the 2 input and OR gate. So, the expression would be F equals to A plus B. So, the plus operator indicates the OR operation. ये वो add वाला symbol नहीं है. The plus sign here indicates the OR operation. The OR gate, I said, was represented by a closed V lying on its side. An alternate symbolic representation of an OR gate is a square with one line at one end representing the output and some more lines on the other end representing the input. Within the square, you have an equal to greater than sign which represents the OR gate. Now, we would be interested in the timing diagram of an OR gate. That is, if a certain set of inputs, continuous inputs, are applied at the input of an OR gate, what would be its output? How would it behave? So, let us have a look at the timing diagram of an OR gate. Let us consider a 2 input OR gate and having inputs A and B. A combination of 1s and 0s is applied at the input A, and again another combination of 1s and 0s is applied at the input B. The timing diagram shows both the inputs A and B. The output remains high for the entire time interval, that is from T0 to T6. Let's see why. Well, considering the time interval T0, the input is high or logic 1, the input B is high or logic 1. Now, referring to the function table or the truth table for the OR gate, the output should be a 1. Considering the time interval t1, the input A is a 0, the input B is a 1. So what should be the output? If any input is 1, the output has to be a 1. Similarly, for time interval t2, the input A is a 1, the input B is a 0. So what is the output? It should be again 1. If any input is a 1, the output has to be a 1. Similarly, if you look at intervals t3, t4, t5 and t6, in these 4 intervals, either both the inputs are logic 1 or only a single input is logic 1. For all these 4 cases, the output has to be a 1. We just looked at the timing diagram of a 2-input OR gate and we observed the inputs and the outputs for a time interval of 7, t0 से लेके t6 तक. OR gate को OR क्यों कहते हैं? Well, the English word OR means this or this. So if you look at the function table, if any input is 1, the output is 1, right? So this or this is a 1. इसी तरह AND gate को AND क्यों कहते हैं? Again, it's the English word AND. That means this and this should give you the output. So if both the inputs are 1s, only then you would have the output 1. If any of the inputs is a 0, then of course the output is not going to be a 1. Let us look at the third gate, the inverter gate. The inverter gate is also known as a NOT gate. Symbolically इसको represent कैसे करेंगे? बड़ा simple सा इसका symbol है. It's a triangle with a line leading into the triangle and another line coming out of the corner of the triangle. At the corner or the pointed end of the triangle, you have a bubble, a circle. Okay, ये symbol represent क्या कर रहा है? Well, the input applied at the NOT gate is inverted at the output. Now, as you can see from the symbol, a NOT gate has a single input and a single output. This is the only gate which has a single input. The output is, of course, 1. Let us have a look at the complete function of a NOT gate. So the function table would have an input column A and output column F. How many combinations can we apply at the input? Since we only have a single input, so you could only apply either a 0 or a binary 1. So if you apply a 0 at the input of a NOT gate or an inverter gate, what do you get at the output? Basically 0 invert होके output पे आ रहा है, so you would get a 1. Now, if you apply a 1 at the input, what do you get at the output? Again वो invert होके आ रहा है, so you would get a 0 at the output. इसको expression की form में कैसे लिखेंगे? इस function को expression की form में कैसे represent करेंगे? Well, if f is the output, so the expression representing the operation of a NOT gate would be f equals to a bar. A के ऊपर bar है. So in digital logic, whenever you see a bar on top of a letter, that means that particular variable has been inverted. So a is an input variable, ठीक है? So bar means वो invert हो गया, and that is equal to the output f. Now, can you have a multiple input NOT gate? Well, we said no. Inverter या NOT gate का काम ये है कि एक ही input को लेके invert कर रहा है उसमें. So it is not possible to have multiple inputs. और output तो होता ही एक है. Now, let us have a look at the timing diagram of an inverter. How would it behave when we apply a set of zeros and ones at the input of a NOT gate? Since the inverter or the NOT gate has only a single input, so you can only apply a sequence of zeros and ones at the input A, which is shown in the diagram. The inverter or the NOT gate has a single output, so the output is shown by the timing diagram represented by F. Let us discuss the inputs and outputs during different intervals. At t0, the input is 1. Since the NOT gate inverts the input, so what should be the output? It should be 0. Similarly, at interval t1, the input is 0. So the output should be inverse of this, so it is a 1. Similarly, during intervals t2 and t3, the input remains a 1, the output has to be a 0. And similarly for intervals t4, t5 and t6, you can see that the output has been inverted. We've just looked at the timing diagram of a NOT gate. Before we move on any further, let's have a look at the use of these 3 gates, the AND gate, the OR gate and the NOT gate. So let us have a look at the diagrams. The AND gate can be used to enable or disable a device. Consider a counter. How does a counter count? Well, it is connected to a clock input. So as the counter receives the clock pulses, it increments its count. So perhaps it is at the number 1, it receives a clock pulse, it increments to 2. It receives another clock pulse, it increments to number 3 and so on. Now, you can disable the counter by stopping the clock pulse from reaching the counter input. So how do you do that? You connect an AND gate to the input of the clock input of the counter. Now, the AND gate has the input A and another input B. The clock is connected to input A of the AND gate, and the input B is connected to a switch. If the switch is set to 1, the AND gate would allow the clock pulses to be available at its output. So the counter would start counting. If the input of AND gate B is disabled or set to 0, what would be the output of the AND gate? It would be 0. So no matter what the clock is, it is high or low, the output would remain as 0. So in fact, by setting the input B of the AND gate to 0, you have disabled the output remains as 0, and the counter does not count. Now let us consider the application of an OR gate. A car has 4 doors, so an OR gate can be used to sound an alarm if any of the 4 doors is open. Let us have a circuit which generates 5 volts when any door is open. So let us suppose all the doors are closed. So the 4 circuits would be generating a 0. If all the outputs of these 4 circuits are connected to the 4 inputs of an OR gate, what would be the output? It would be a 0. Let us suppose the front left door is open. The circuit would generate 5 volts. Now this is considered to be a logic 1. So what are the inputs to the OR gate? Well, the 3 inputs would be 0. The single input which is connected to the circuit of the front left door would be 1. What is the output? It is a 1. Now the output of the OR gate is connected to an alarm. So now whenever any of the 4 doors or all 4 doors are open, the inputs would be 1s corresponding to the open door. The output would of course be 1 and the alarm would be sounded. Let us consider the application of NOT gate. We talked about calculating the 2's complement of a number. So how do you calculate the 2's complement? Well, you first calculate the 1's complement. How do you calculate the 1's complement? You basically invert the entire number. So if the number is 1 1 0 0 1 0 1 0, its 1 complement would be 0 0 1 1 0 1 0 1. So how do you perform this 1's complement? By using NOT gates. So how many NOT gates do you require? Since the number is an 8-bit number, so you would require 8 NOT gates. We've just looked at applications of the AND gate, the OR gate and the NOT gate. Now before we move on, let us look at alternate representations of the AND gate and the OR gate. Symbolically, the AND gate is represented by a closed U lying on its side. The AND gate symbol can also be represented by the OR gate, the closed V symbol. But the inputs have bubbles and the output also has a bubble. So the general rule is, if you need to represent a gate by its alternate symbol, you just select the other symbol. अगर AND gate का symbol है, आप उसका alternate symbol क्या है? OR gate का symbol, वो select कर लें. The other thing which you need to do is to put bubbles at the inputs and the outputs जहाँ पे पहले नहीं है. So if you consider the original AND gate symbol, it does not have bubbles at the inputs or the outputs. So when you select the alternate symbol, which is the closed V, you would put bubbles at the inputs and the outputs. Okay. इस symbol को अगर हम define करें, पढ़ना चाहें, what does it represent? The OR gate symbol indicates this or this, right? So since a 2-input AND gate has 2 bubbles at the inputs, that means 0 or 0, what should be the output? The output again has a bubble. So the output is 0. So this means this 0 or this 0 would give you a 0 at the output. Now if you look at the function table of an AND gate, what do you get at the output? Well, if any of the inputs is a 0, the output is a 0. So ये जो alternate symbol है, ये exactly उसी चीज को explain कर रहा है. Let's look at the OR gate symbol. The OR gate symbol is of course the closed V lying on its side. The alternate symbol which represents the OR gate is the AND symbol. इसके जो inputs हैं, outputs हैं, उधर सारों पे आपने एक bubble डाल देना. Bubble, what does the bubble mean? It means invert हो रहा है, right? So let us see what this alternate symbol for an OR gate represents. It means 0 and 0 should give you a 0 output. Right? Now, if you just remember or you look at the function diagram or the truth table of the OR gate, 1 कब आता है? If any of the inputs or all inputs are a 1. If both inputs are a 0, what do you get? The output is a 0. So this is what the second symbol represents. We have just looked at the alternate symbolic representations of the AND gate and the OR gate. In the handouts, I have given some examples, so that would help explain the alternate representations of the AND gate and the OR gate. By the way, the inverter gate can be alternately represented by a bubble not at its output but at the input. So inverter भी दो तरीकों से आप represent कर सकते हैं symbolically. Now let's go back to the gates. We have talked about AND gate, OR gate and NOT gate. Let's continue our discussion with the NAND gate. NAND gate basically, again, it has multiple inputs and a single output. The number of inputs has to be more than one, and of course ज़्यादा हो सकते हैं, 10-12 हो सकते हैं इसमें. What does the NAND gate do? Basically, it is a combination of the AND gate and a NOT gate. So if you connect a NOT gate at the output of an AND gate, that would give you a NAND gate. Let us look at the function table or the truth table of a NAND gate. Let's consider the two input NAND gate. So what are the inputs? A and B. What is the output? F. Again, कितनी combinations होंगी? It's a two input NAND gate, so you have 4 different combinations: 0 0, 0 1, 1 0 and 1 1. Output क्या होगा? Well, for 0 0 the output is a 1. For the combination 0 1, what is the output? Again it's 1. For the combination 1 0, what is the output? Again it's a 1. For the input combination 1 1, what is the output? It is a 0. Now, if you compare the output of a NAND gate with that of an AND gate, you would see a direct inversion between the two outputs. So that's what we explained earlier. NAND gate is made up of an AND gate along with a NOT gate connected to its output. Let us have a look at a mathematical expression which describes the function of a NAND gate. Well, we are using a two input NAND gate, so it has inputs A and B. So the expression would be F equals to A dot B and bar over the entire expression. Bar, we said, represents the inversion. So in fact, the product of A and B is being inverted. Symbol क्या होगा NAND gate का? Well, it is very similar to that of the AND gate with a bubble at the output, which indicates that the output is being inverted. Let us have a look at the timing diagram of a NAND gate. Again, we apply a certain number of inputs, rather a train of binary numbers at the inputs, and we observe the output. And we simply draw a timing diagram which explains the behavior during that particular time interval. Let us consider the example of a two input NAND gate. You apply a series of ones and zeros at both the inputs A and B, which are shown in the diagram. The output F is again shown in the diagram. Let us consider the time interval T0. At time interval T0, both the inputs are a 1. What should be the output? Referring to the truth table of the NAND gate, the output should be 0. Whenever all the inputs are 1s, the output is 0. Consider the time interval T1. The input B is a 1, whereas input A is a 0. So what should be the output? Referring to the function table or the truth table of the NAND gate, if any one of the inputs is a 0, the output is going to be a 1. So during time interval T1, you see a 1 at the output. Similar is the case with time interval T2. Input B is a 0, so the output has to be a 1. Looking at interval T3, both the inputs are 1s, so the output has to be a 0. Intervals T4, T5 and T6, you see an output which is high or 1. Why? Because during intervals T4, T5 and T6, one of the inputs is a 0. We have just looked at the timing diagram of a two input NAND gate. Before we move on and talk about the universal NAND gate, let us talk about a 3-input or a 4-input NAND gate. Do we have a 3-input, 4-input NAND gate? Yes, NAND gate can have multiple inputs, more than 2 inputs, like the AND gate and the OR gate. फंक्शन टेबल क्या होगा इसका? लेट्स से ए 4 इनपुट NAND गेट. अगेन वही वाला जो AND गेट के केस में और OR गेट के केस में था. You have inputs A, B, C and D. You have 16 possible combinations. So you have 16 possible outputs. So NAND 4 input NAND gate का output क्या होगा उसमें? Well, again, if all the 4 inputs are ones, what do you get? You get a 0. For all other combinations, you would get a 1. 4 input NAND gate का expression, mathematical expression जो है वो क्या होगा? Well, basically it is F equals to A dot B dot C dot D, an entire bar over the entire expression, which indicates that of course the product of A, B, C and D is being inverted. Now let us see why we call a NAND gate a universal NAND gate. Well, if we have a NAND gate, we can use the NAND gate to implement an inverter, a NOT gate. We can use it to implement an AND gate. We can use it to implement an OR gate. Let's see how we can use a NAND gate to implement an inverter. Okay, let's consider a 2-input NAND gate. What happens if you connect both the inputs together? So now, if you connect both the inputs together, you can only apply a single input. Single input क्या होगा? यहाँ 0 होगा या 1 होगा. Right? Now, if you look at the function table or the truth table of a 2-input NAND gate, you are left with two options: the 0-0 option and the 1-1 option. 0-1 और 1-0 combination possible ही नहीं है क्योंकि आपने दोनों inputs connect कर दिए. So what do you get when you have two zeros, 0-0 at the input? Well, the output is a 1. What do you have when the two inputs are a 1-1? Of course, both the inputs are connected together, so you have basically a 1. The output is going to be a 0. Now, what happens if you have a 3-input NAND gate and you connect all the 3 inputs together? Would you obtain an inverter? Yes, since you can only have two combinations, either all 3 zeros at the inputs or all 3 ones at the inputs. So what do you get when you have all 3 zeros at the 3 inputs connected together? Of course, the output is going to be a 1. जब आप 1 apply कर रहे हैं, then of course the output is going to be a 0. Now let us see how we can use an AND gate to implement an AND gate. And NAND gate basically क्या है? It is an AND gate with an inverter connected to the output. So if you connect another inverter at the output of an AND gate, what happens? The two inverters cancel each other out and you are left with an AND gate. How do you obtain an OR gate using an AND gate? Well, you have to use a combination of 3 NAND gates. Now, to explain this conversion or implementation of an AND gate using an AND gate and the implementation of an OR gate using a combination of 3 NAND gates, let's have a look at the diagram. Let us first look at the implementation of an AND gate using NAND gates. NAND gate 1 functions like a NAND gate. The output of NAND gate 1 is shown by F1. Now, this output has to be inverted so that we have an AND gate output. Another NAND gate 2 is used as an inverter. Both its inputs are connected together and they are connected to the output of NAND gate 1. Now, if you look at the function table, the output of NAND gate 2, which now has been connected as an inverter, is 0001, which is the function table or the truth table of an AND gate. Now, let us see how we can implement an OR gate using NAND gates. An OR gate can be alternately represented by the AND gate symbol with bubbles at the output and the inputs. Now, if you just discard the bubbles at the input, what do you see? You see an AND gate. What do the bubbles mean? Well, bubbles indicate an inverter. So, the two bubbles at the two inputs mean two inverters. So, how do you implement an inverter? By connecting the two inputs of a NAND gate. So, the circuit which represents the OR gate is implemented by using 3 NAND gates, 1, 2 and 3. NAND gates 1 and 2 are connected as inverters and NAND gate 3 is used as a NAND gate. The function diagram confirms the operation of this 3 NAND gate circuit as a OR gate. We've just looked at two circuits which describe the use of an AND gate to implement an AND gate, and another circuit which described the use of an AND gate to implement an OR gate. Let us now look at the NOR universal gate. The NOR universal gate again can be used to implement an OR gate, an AND gate, an inverter and an AND gate. So before we describe how we can implement all these circuits, let's have a look at the NOR gate. NOR gate basically combines the OR gate and a NOT gate. So that means if the output of the OR gate is inverted, what do you get? You get a NOR function. Let's have a look at a 2-input NOR gate. So what are the combinations? Again, you have 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. What should be the output? Okay, what was the output for the OR gate for the combination 0, 0? It was a 0. Since the NOR gate is inverting the output of the OR gate, so you should get a 1. Similarly, for the input 0, 1, what should be the output of the NOR gate? It should be the reverse of the OR gate. So the output should be a 0. Again, for the combination 1, 0, the output should be a 0. And for the input combination 1, 1, the output of an OR gate again is a 0. Symbolically, NOR gate को कैसे represent करेंगे? It is very similar to the OR gate except for a bubble at the output, which indicates that the output of the OR gate is of course being inverted. इसको expression के तौर पे कैसे लिखेंगे आप? Well, F equals to A plus B whole bar. That means the entire expression is being inverted. Multiple inputs, that means let's say 4 input, 5 input NOR gates होते हैं? Yes, बिल्कुल होते हैं इसमें. Let's have a look at a 3 input NOR gate. कितने outputs होंगे? Well, 3 input NOR gate के 8 possible input combinations हैं. So we have 8 possible output values. क्या हो सकती हैं इसमें? Well, for the combination 0 0 0, you would have a 1 output. For all other combinations, you would get a 0 output. इसको एक्सप्रेशन में कैसे लिखेंगे? The 3 input NOR gate, basically f equals to a plus b plus c whole bar. Plus, as you remember, we said it does not indicate addition, it simply indicates an OR function. The bar indicates the NOR function. Let's have a look at the timing diagram. Again, let's suppose we have a 2 input NOR gate having inputs A and B and of course the output F. We apply a certain number of inputs at input A and B. Let's observe the output through a timing diagram. A sequence of 1s and 0s is applied at the 2 inputs of the NOR gate A and B as shown in the diagram. The output of the NOR gate for intervals T0 to T6 is shown to be 0. Let's see how. At interval T0, the inputs, the 2 inputs are both 1s. What should be the output? Looking at the function table of the NOR gate, the output should be a 0. Again, for time interval T1, the output, rather the input B is a 1. So the output should again be a 0. So if any of the 2 inputs is a 1, the output should be 0. So if you look at intervals T2, T3, T4, T5 and T6, either both the inputs are 1s or only a single input is a 1. Therefore, the output has to be a 0. We just looked at the timing diagram of a 2 input NOR gate. Now let us look at the NOR gate as a universal NOR gate. Why did we say it's a universal NOR gate? Well, we can use it to implement any other gate. Let's again start by implementing the inverter. So how do you implement an inverter or a NOT gate using the NOR gate? Again, if you just join the 2 inputs or the inputs, 3 inputs, 4 inputs together, you get an inverter. If you look at the function table of an NOR gate, when all the inputs are zeros, what do you get? You get a 1. When all inputs are a 1, what do you get? The output is a 0. So basically, you have implemented an inverter. How would you implement an OR gate and an AND gate using an OR gate? Well, implementing an OR gate is very simple. NOR gate हमने बताया था क्या है? Basically, it's an OR gate and the output of the OR gate is being inverted. So if you put another inverter, the 2 inverters cancel out and you end up with an OR gate. So NOR gate, आप एक लें, उसके inputs मिला दें, that becomes an inverter. You just connect it to the output of another NOR gate. That gives you an OR gate. Implementing an AND gate using a NOR gate would require a combination of 3 NOR gates. For that, we would be looking at a diagram, but we would be looking at this diagram in the next lecture. Let's stop for today. Today, we looked at logic gates, which are the basic building blocks in any digital circuit. We talked about the 3 gates, the basic gates, AND gate, OR gate and NOT gate, and then we talked about the 2 universal gates, the NAND gate and the NOR gate. Inshallah, we would be continuing with these 5 gates in the next lecture. See you in the next lecture. Khuda Hafiz and Assalamu Alaikum.